periodic table of elements is a large table that arranges all of the chemical elements known to man and woman. In the depth of Russia lies Dmitry Mendeleev, suffering in chemistry, like us, now. He was having trouble finding any good chemistry textbooks, so just like any regular, normal, sane student would do, he wrote his own. As he did, he found that if you arranged the elements of increasing atomic mass, the sum of protons and neutrons within an atom, their chemical properties showed definite trends, and society loves that. Mendeleev put the known elements in an 8-column grid, each grid representing a set of elements with similar qualities. Those qualities, you ask? Hopefully ones that get them friends. At this time, there were only 63 known elements. His table became popular as it correctly predicted properties of elements that had not been discovered yet. And when they were discovered, he had left spaces just for them. The periodic table has now long since filled the gaps and added new elements and has entirely changed from Mendeleev's original version. Our current periodic table consists of 118 elements we can categorize into roughly 3 types and 11 families, each with their separate but quite similar qualities. Those being metals, metalloids, and nonmetals, alkali metals, alkali earth metals, transition metals, the boron family, the carbon family, the nitrogen family, the oxygen family, the halogen family, noble gases, the lanthanide series, and actinide series. The elements are arranged from left to right and from the top to the bottom, and they are now in order of atomic number, the amount of protons in the atom. This change happened because the atomic number is unique to each element, whilst the number of neutrons can vary, creating 2 or more isotopes of the same element. Electronegativity is a measure of how strong an atom can attract bonding electrons to themselves. It's influenced by an atom's atomic number and the atomic radii. The Pauling scale, most commonly used for this procedure, was named after the first scientist to propose a measurable scale for electronegativity and to completely define the concept. Based on this website, Pauling based his scale on bond energy calculations for different elements joined by covalent bonds, a type of chemical bond formed when atoms share electrons. The higher the value on Pauling's scale, the greater the strength of the atom to attract electrons. If we know the values for electronegativity of 2 adjacent atoms in a chemical compound, we can use it to find out the qualities of the chemical bond between them. If there is little or no difference, electrons are evenly shared between the 2 atoms and the bond is covalent. The general trend of electronegativity is for the energy to increase across a row on the periodic table, or better known as a period, and decrease down a group. Ionization energy is the energy needed to remove an electron from an atom. This is not to get mixed up with electropositivity. This energy is often expressed in a measurement called joules and is, quote, usually measured in an electric discharge tube in which a fast-moving electron generated by electric current collides with the gaseous atom of the element, causing it to eject one of its electrons. The general trend of ionization energy is basically the same as electronegativity. The energy increases along periods and decreases down groups. Atomic radii is the distance of the outermost electron shell away from the nucleus of an atom. Atomic radius decreases as you go along the periods and increases as you go down the groups. With period trends, as you go across a period, protons are being added to the nucleus increasing the positive charge inside. The increase pulls the electrons closer to the nucleus, meaning a smaller atomic radius. With group trends, that outer shell increases in size when you move down the groups, making the atom larger, so the atomic radius increases as the groups increase. To determine the atomic radius, you first must measure the distance between nucleus of two atoms of the same element, and then divide by 2.